Let's take a look at our quadratic functions in the form of y is equal to ax squared plus bx plus c. So if we're pulling from the last lesson, a quadratic function is a function with a degree of 2, which can be written in the form of f of x is equal to ax squared plus bx plus c using our function notation, or an equation as y is equal to ax squared plus bx plus c, where a, b, and c have to be real numbers and a cannot equal 0. The graph of this is a parabola. It's that arch that is symmetrical and opens up or opens downwards. If we're looking at the basic characteristics of a graph, a parabola has either a maximum or minimum point if the parabola opens down. In this case, we can see that for this one it opens down and it's got a highest point that exists there. It also has a minimum point if it opens up, and I can see the lowest point. The vertex is the value or the coordinates at the maximum or minimum point. So if I have a lowest point here, that coordinates is my vertex. If I have a highest point here, that coordinate is my vertex. The maximum or minimum value of the quadratic is the y-coordinate at the vertex. So if we're using a quadratic function, y is equal to x squared minus 6x plus 5. Then what we can do is we can graph this into our calculator, saying that y1 is equal to x squared minus 6x plus 5. And to start, we can go to the table or hit second graph, or if you're on a Casio, go to the menu and the table function and find what the y values would be if that was the x values. You can do the same thing by replacing -1 for x and solving for y, 0 for x and solving for y, so on and so forth. So when x is -1, y is 12. When it's 0, y is 5. When it's 1, y is 0. When it's 2, y is -3. When it's 3, y is -4. 4 and -3. At 5, it's going to be 0. At 6, it's going to be 5. And at 7, it's going to be 12. I'm going to plot these points on the graph. So I'm going to start at my point of -1 and 12. Then I go to 0 and 5, 1 and 0, 2 and -3, 3 and -4, 4 and -3, 5 and 0, 6 and 5, and 7 and 12. I'm going to smoothly connect the points and extend it off, knowing that the graph is going to continue moving up and to the left and up and to the right. We're going to draw a vertical line representing the axis symmetry. So we're going to draw a vertical line through the vertex, or the lowest point. And we can see that the graph is exactly symmetrical on both sides. It's just one big reflection. Next, we're going to state that the graph of a quadratic function, y is equal to x squared minus 6x plus 5, is a parabola. The vertex, or lowest point, is going to be at the coordinates of 3 and -4. This parabola opens upward and has a minimum or lowest point. The minimum value is the y value at the vertex. In this case, it's -4. The x-intercepts occur at when x is -1, when x is 1 and when x is 5. We can also think of x-intercepts as always meaning what is the value of x when y is equal to 0. The y-intercept occurs at 5. The y-intercept is also going to be the value of y when x equals 0. The equation for the axis symmetry is always going to be in the form of x equals. Any vertical line represents x equals. So if I'm looking at this line and I said x equals, well, the value of x all the way through this line is always 3. You can also state the axis symmetry in terms of x equals the x value at the vertex. If the vertex is 3 and -4, it would be x is equal to 3. The domain is easy because for any of these quadratics, the domain is always the same. It keeps moving to the left, it keeps moving to the right. The domain, represented by x is an element of all real numbers. The range is a little more tricky. It's represented by y, and in this case, it has a lowest point that y hits, but y can be anything equal to or above that point. Y is greater than or equal to -4, where y is an element of all real numbers. How can the equation of the axis symmetry of the graph be determined from the x-intercepts of the graph? Well, if it's symmetrical on both sides, then that means that it has to expand out equally from that axis symmetry. So from this vertical line, it moves 2 to the left or 2 to the right. So the axis of symmetry has to be exactly halfway between the two intercepts. So if I want to say, how can I find it? If it's halfway between, I can always solve for the halfway point of anything by saying that it's going to be 1 plus 5 divided by 2, or the x-intercept plus the other x-intercept divided by 2. I'll let you follow through these instructions, solving it on your calculator. It is slightly different on the Casio calculators, but it basically works the same way. You're going to graph your function, and then if you want to determine the minimum or maximum value, you're going to hit second trace, or you're going to solve for, does it have a maximum or have a minimum? If it looks like this, where it's arching down, you're solving the maximum. If it arches up, you're going to be solving the minimum.